Unit 7. Oh, here we go. We're going to do notes on common ArrayList errors, just a compilation of things. Then we're going to do a program that uses the word group class we wrote last time. And if you didn't write it, that's okay. I give it to you today. And then we're going to learn about sorting. There's 2 different types of sorting algorithms that you're going to see today, and you need to be able to recognize them. You don't have to code them, but you have to be able to say this is an insertion sort or a selection sort. And then we're going to do a Google form, and we have a worksheet, and then we have another REPL. So here we go. Common ArrayList errors. I'm just going to start by saying ArrayLists are awesome. I'm not dissing them. It's awesome. You create a thing, and you put in the data you need, and you can take things out, you can move them, all kinds of things. But don't confuse arrays with ArrayLists. They're very different. An array, you can't resize. You create it, and you say, I want to create this, and it has 1,000 elements, and then you can't make it have 900 elements. It's always going to have 1,000. Also, you have to use get, and .set with ArrayLists instead of square brackets. And with ArrayLists, you have to use .size instead of .length with no parentheses. ArrayLists only hold object data, so not primitive data. You can't make an ArrayList of int variables. That's why we use capital I integer, because that's not a primitive variable. You have to say what type of object you'll be storing in the ArrayList at the time of creation. So like this line up here, ArrayList string words equals new ArrayList string. So it's possible to leave the thing out on the right side, but Replit will complain, and I will not give you credit if you don't put the thing on both sides. So put the thing on both sides, please, the string and the string. This shows up on the AP Classroom where there's a question that we'll do on Wednesday next week, where they don't put it on the right, and you're all going to think, oh, that's wrong. But I told you it's not technically wrong, but it's not a good way to do it. So I don't know why they have that question in there, but some kind of legacy thing. Don't forget the parens at the end when you're creating a new array list right over here. Don't forget those parens, because that tells Java to call the constructor. And remember, if you're going to maybe remove some things from an array list, you need to start at the end and work backwards. So here's a good example of that. If I'm deleting anything that is equal to temp, you have to start at the back and work backwards. Otherwise, it doesn't necessarily work the way you think. And here's some advice. You probably haven't run into this, but don't change the size of an array list if you're using an enhanced for loop. So if you're using an enhanced for loop, don't add things to it or remove things from it. And if you do, it'll crash. And it says concurrent modification exception error. You don't have to memorize that, but just bottom line, if you're using an enhanced for loop, like I did with the warm-up, it's great for accessing the data, but don't be trying to add things to it while you're in an enhanced for loop. So, because it'll crash. If you want to change elements in an array list, use a regular for loop, not an enhanced for loop. And then use .get and .set. So this is an example of going through an array list called words and setting everyone to be uppercase. So I say words.set, and then I'm setting element I, that's the index. But first I'm getting element I and setting it to uppercase, and then that's what's getting stored in element I. So it's kind of a lot, but that's like saying words square bracket I equals words square bracket I dot to uppercase. A little bit less complicated with an array. All right, this is not an error, but just an overview of the ways you can access an array list using a for loop. You can start I equals 0 and I less than array.size, I plus plus. You can do I equals 0, I less than or equal to array.size minus 1. You can start at the end and say it's as long as I is greater than or equal to 0, or you could start at the end and go as long as I is greater than -1. if you're going down. It's just, these are different things you can do. And by the way, I don't know if I did mention it, but I'm just reiterating it. It's not an error, but the dot remove method hands you the thing that got removed. So check out this example. I made an array list called names. I added 2 names, and then I printed out names.remove1. That prints Elvis. It deletes Elvis from the list and hands it to the print call. You don't have to print it. You don't have to do anything with it. Here's another example. Same array list names. I added Gilly, Elvis, and Gandalf. I said string old name equals names.remove remove 1. That takes Elvis and stores it in old name. And when I do names.remove 0, that deletes Gilly. And then I can say system.out.println names.remove 0, and that removes the last Gandalf. So now we have an empty array list. But line 5, I'm using the dot remove and storing what got removed in a variable. Line 6, I'm just removing something and throwing it away forever. I'm not storing it anywhere. And line 7, I'm removing something, and I happen to also be printing the thing that got removed. So these are just different ways you can use dot remove. August.
This string old name equals names.remove1. Are you basically assigning string old name to that variable remove, or
I'm setting the variable old name to be equal to what was at index 1.
Yeah.
And then index 1 is removed.
Cool.
Yeah. That again also shows up, I think, on the AP classroom. So any questions on these errors or notes? You'll get to keep practicing. I'm giving you extra time this unit because of the way the Monday holidays are following. So next week, both days we're going to review, and then the following Monday we're going to review, and we have a test a week and a half from now, Wednesday the 31st. So I think you'll have plenty of time. All right, now we're going to talk about sorting, everybody. In AP Computer Science, there are 3 sorting methods that you need to be familiar with. So you won't be asked to code them on the AP test. I may ask you to code 1 or more of them, but I'm not going to ask you to code them in this unit. So today we talk about 2 of them, something called the insertion sort and another one called the selection sort. And you're just going to need to figure out a way to memorize which is which. So we're going to start with the insertion sort, and I'm just going to describe the algorithm, and then I'm going to show it to you. So if we're doing an insertion sort, we're working with a list, whether it's an array or an array list, anything you're going to sort. You start at the second item of the list, and then you go backwards towards the beginning and see, should this second item go before anything to my left? And if it should, then you insert it there, like remove it from where it was and insert it at that spot, bumping everything up. And then you go to item 3 and you say, hey, should item 3 go anywhere to the left? And if not, you leave it there and you go to item 4. But say you get to item 4 and you see, should item 4 go anywhere to the left? And then if you do, you insert it and everything else bumps up to the right. And you have to do this all the way through the list until you get to the very end. So what would this look like in our class? On the AP Classroom, you might be asked to say which sort was going on, given some data. But more often, I'm going to ask you to tell me what's the next line. If I was sorting these numbers with an insertion sort, what does the next line look like? So we're going to look at both scenarios. Right here, I could say, what's so interesting, Brennan and Jack, that isn't what's up here? I know you're grinning and looking at Jack's computer screen and not at what I'm doing. And I've recorded your names forever on my video. I do apologize for that, but nobody's going to watch this video, so don't worry. Okay, so right here, anybody want to give me a shot? What's the next line look like if we're doing an insertion sort? Remember the rule. Start at number 2 and see if that item should go anywhere to the left. I mean, the left. Well, I'll tell you, it should be after one pass of an insertion sort, this will be 2, 5, 6, 1. Because we look at the 2, like if I'm doing it on paper, I put my pencil on the 2, and so I can keep track of what I'm looking at. I say, should this go anywhere to the left? Well, yeah, I think so. So you insert it before the 5 gets bumped over. So now, the next pass of the insertion sort, we're looking at the 6. And so should the 6 go anywhere to the left? No. So sometimes there's a pass and nothing changes. I mean, I know as humans, we could look at this and go, well, I know the 1 has to go first. Let's put it there and stuff like that. But imagine there were a million items. You need to have some sort of system. And this algorithm works. All right. In the next pass, we're looking at the 1. And clearly, the 1 has to go all the way to the left. So the way it technically works is that the 1 is there, and then it checks every single one. Should I go before you? Should I go before you? Should I go before you? And finally gets to the 2 and goes, oh, yeah, I should go before you. Inserts itself in front. So I think it's safe to say that the number of passes would be 1 less than the length of the list, because it doesn't have to check the first item because it starts at the second item. You're going to have this slide deck, but this is a valid insertion sort code that I got from the AP Classroom. It's called insertion sort, and it uses a regular array, not an array list. I guess I said, let's walk through this code. It's a little scary, but let's look. It's starting at item 1, remember the second element, and it's going to go up to the end, and it takes whatever element it's on and stores it in a variable temp, and it sets possible index to that number. Not to where it's at. So it's at number 1 and possible index is 1. So we're temp is equal to 8. And then it's while possible index is greater than 0 and temp is less than the previous number, it's just trading places. So it's not doing exactly what I said. It's not going all the way to the back and then swapping once. Because it's an array, it's like, oh, okay. If I'm not all the way to the left and the one before is less, is greater, I'm gonna switch them. So it's like, go switch, all the way down. So here's the output of that code. I added a print call at line 10 so we could see what came out. So the start at line 10, just for a second, it put the 10 over here, and then it put the 8 there. Okay, now it's looking at the 10 and the 3, and it knows it has to move that, so it puts the 10 there, and then the 8 there, and then the 3 there. Anyway, it's following this code is non-trivial, but you're going to have problems where it says, what is the value of possible index after 3 passes of an insertion sort? And then, it's up to you whether you want to try to figure that out. You'll have access to that code. So what's great about an insertion sort, it's relatively easy to code, and it's quick for small data sets. But it does get very inefficient for large data sets. A lot like, remember the linear search? Linear search is easier to code, but it is also inefficient for large data sets. So I know that's not trivial code, but it's like 8-10 lines of code. That's not too hard of a sort. But if you had 100 million data points and you had to sort that, it could take a long time. It's not as efficient as some other ways. So that's the insertion sort. So let's talk about the selection sort. I think I like this one better. Start at the beginning, element 0, go through the whole array and find the smallest element. And then trade places with the one at the beginning and that smallest element. Did somebody just say, "Oh no"? It's awesome though. You're like, all right, it's like my fingers on the first one. Oh, found one that's the smallest one. You trade places. Then you go to the second one, and you go to the whole rest of the array, find the next smallest, the smallest one of what's left. Trade places, and you just keep going all the way through. So, looking at this, here's the starting data, the Jenny number. We got our finger on the 8, but we're going to go through the whole thing and find the smallest number. It's 0, right? Then we're going to swap the 0 and the 8. So pass 1, swap the 0 and the 8. Next pass, we got our finger on the 6. We're going to go find the smallest number to the right, including the 6, possibly. It's the 3, right? We're going to swap the 3 and the 6. Now we got our finger on the 7. Find the smallest number. It's a 5. We're going to swap the 5 and the 7.
I think this might be my favorite.
I do love this one. It's not like as a human, you're like, well, come on, don't put that there. It'd be quicker if you put it there. But that's just because we could see, but you have to have some kind of rule. Now we're on the 7. We're going to find the smallest number. It's a 6. And it looks like it's sorted. Now, Java don't know, though. So then it does a few more passes, but nothing more would change. So, and that's okay. The end passes take less time because they're shorter. So same thing here. Here's a selection sort. No. It's not so bad. Here's a outer for loop, starts at 0, goes all the way to not the very end, because you don't have to sort the very end. It's already in the right place. And you keep track of the smallest number. And then this code goes through the whole array to the right, finds the smallest number. Hey, I'm going to find the smallest number. And it keeps track of the index of the smallest number. And then it checks here if the current number is not equal to the smallest number, then we're going to swap them. And it just takes the one at J, stores it in temp, replaces the J with the smallest number, and then puts that J number in the, just swaps them. And then it goes and does it again. And so anyway, this does look a little crazy, but it's actually easier to read than the other one. Again, the sort method is relatively easy to code, quick for small data sets, but it also gets very efficient for large data sets. Same issues as the insertion sort. And both these algorithms work equally well with arrays and array lists. Let's practice an insertion sort. So I want you on a piece of paper to write down what 3 passes will do with this data. An insertion sort. That's the first one, the first type. Get a piece of paper out, get a pencil. Put on your big boy pants. I got pencils by the globe. If you don't have a pencil, go get one. How about this? You're going to turn this paper in. So put your name on it. And it's getting real. It's getting real in the Whole Foods parking lot. What is the deal with the little shopping carts they got?
What's the deal, Al?
So, could somebody who's brave tell me what happens on the very first thing on an insertion sort? Do we start by looking at the 8 or do we start by looking at the 6? Insertion sort starts with the second element and checks if it should go to the left. So label your passes. Like say pass 1 to the right and write the numbers all down. So I'm giving you this one. Pass 1, 68793. You heard me say I'm collecting this.
does the 6 and 8 switch?
Remember, we're grabbing the 6. This isn't the second sort, it's the first sort. We're looking at the 6. Should the 6 go anywhere to the left? Yes. We insert it before the 8, bounce the 8 over. Now we're looking at the 7. Should the 7 go anywhere to the left? Yes, it should. And the 8 gets bounced over again. Now we're looking at the 9. The 9 doesn't need to move. So there's a pass that you have to account for. It's pass 3. Has no change. But I'm going to require that you write it down.
How's the 3 on the 6? Can't swap it with 6. Take the 3 on the 6.
This one isn't the trade places. This is just inserting it. So the last pass, we're looking at the 3. Where is it? Just should the 3 go to the left? Yeah, all the way to the left. So pass 4, we're done. And there's no more passes. This is insertion sort. Write down insertion sort. Write your name at the top. The insertion sort, you know with the insertion sort that the list is fully sorted to the left after each pass. What's on the left is sorted. And then you just take a new element and you go basically put it in the right place. Yes?
So the 3 doesn't go through every number to the left, it just goes straight to the front?
Well, that implementation that we saw moves it one by one, but the real method is take it all the way to the left, insert it, everything bumps over. Like if it was an array list, we'd insert it at element 0, and then everything would just get renumbered. All right, we're going to do the same data, but with a selection sort. Draw a line and write selection, and start over. 8, 6, 7, 9, 3. So this one's different. See if you can get past 1 all by yourself. This is the second sort that we did, called the selection sort. Put your name on this paper. I'm going to collect it. Remember, this is the one we start at the first element, and we kind of got our finger on there, and then we find the smallest number in the whole array, and we trade places if we need to with the current one and the smallest one. It goes through the whole array on the first pass. Well, it doesn't check the 8 because 8 it already knows what it is, but it checks all the other ones. Is there anything smaller? So pass 1 is right up here. Now we got our finger on the 6. Starting at the 6, what's the smallest number, including 6, in the whole array? 6. So nothing happens. Pass 2, no change. The 3 and the 8 swap, because with this sort, we find the smallest number and put it in the first spot. And then we're on the second spot, and we find the smallest number, ignoring the 3. From 6 all the way to the right, what's the smallest number? 6, no change. Then we go to the 7. From 7 all the way to the right, what's the smallest number? 7, no change. So we have 2 passes, no change. Then we start with the 9, and we say, starting with 9, what's the smallest number? 8. Then we swap the 8 and the 9. That's eh, all right, make sure your name's on that. Pass it to the end. Jacob.
But what if you have two variables with the same model?
Then it doesn't trade them. Yeah, it only trades them if it finds something smaller.
Same kind of thing.
Yeah, it doesn't move anything if it doesn't have to. All right, good people, I'm going to stop the notes.